through these problems, if you don't mind. All right. What does the first problem say? What's the equation?
It's f at x equals x squared negative minus 4x plus 4.
Okay. So we're able to decipher just by looking at it. It opens up. And then maybe let's list our A, B, and C values. And we're going to use x equals negative b over 2a. That's going to find us the axis of symmetry. Also find us the x value of the, excuse me. So let's see. I'm going to get negative 4 over 2 times 1. That's plus. So that's 4 over 2, which is 2. So my vertex is going to be 2 comma. So yeah, I got 2 squared. That's 4, right? Minus 4 times 2, negative 8, plus 4. So that should be, gives me 0. Let's save my things. Paste that. There. Let's pull up that XY axis too.
I wasn't familiar. I can't remember. Up one right one, up one right three, and then up one right. I mean, I'm checking what I'm. How do you do that? Is it right one, up one, and then like right one, up three or something like that?
1, 3, 5. All right, here we go. So my vertex is at 2 comma 0, so it's right there. My axis of symmetry is this imaginary line right here. And then we're going to use the 1, 3, 5. So the 1, 3, 5 is going to work nicely for us. What's my A value? 1. So does it grow by 1, 3, 5 without any problems?
Yeah.
So my vertex is there. So I'm going to go right 1 up 1, left 1 up 1. From that point, I'm going to go right 1 up 3, left 1 up 3. And I guess I could go right 1 up 5, 3, 4, 5, and left 1 up 5. We just got lucky that we had enough room on our grid to do it.
Is that just a coincidence how that works? Because, like, even if you have a coefficient in front of the A value, you can still do that kind of 6.
Yeah.
And that's all.
So the neat thing about it is because as I go to the right or to the left, and we're mainly just looking at the right because we know it's a mirror image. So from the vertex to the right, the point to the right, the slope of that is going to be 1, or it's going to be whatever the A value is. And then if I go from that point to the next point, so the slope between here and here is 1, here is 3, here and here is 5, or 5 over 1, 3 over 1, 1 over 1, same idea. And then you have the mirror image over the axis of symmetry. So it doesn't happen on accident. It's like that's kind of how it works, which is cool. The reason it does work though is if I were to take all the perfect squares and I were to subtract from, if I were to go from 16 to 9, the distance there is 7. If I go from 9 to 4, the distance there is 5. If I go 4 to 1, the distance there is 3. From 0 to 1, the distance there is 1. So it's the perfect squares. It's the difference between perfect squares that works. So it all kind of, for all those reasons. What's the next problem say?
F at x equals negative x squared plus 4.
Okay. Paste. All right. So, am I missing a value up there? If so, which one? The B. The B value is gone. So my A value is -1. my b value is not there, and my c value is 4. So if I use x equals negative b over 2a, you know, I can go and plug in, but I'm going to get this. Negative 1, that's a negative 1 right there. So 0 on top gives me always 0. So my axis of symmetry is x equals 0. The x component of my vertex is 0. If I plug 0 in here, I get 0 squared. It's negative. Well, it's still 0 squared plus 4. So my vertex is going to fall at 0, 4. 2, 3, 4. My axis of symmetry is right here. Okay. Is this going to grow at 1, 3, 5? Negative though. Because I have this right here, that means negative, negative, negative. So I'm going to go right 1, down 1, left 1, down 1. From that point, I'm going to go right 1, down 3. Hey, look at that. I just found what? Roots. Then right 1, down 5. 5. Left 1, down 5.
When there's only two terms, like the x squared and then the 4, because it's just plus 4, I think you just go directly to the 4.
Could, yeah, that's definitely what's happening. So there's a root there, there's a root there. Did the last one have roots? I don't remember. Oh, where'd it go? Oh yeah, this one had a root right there, wasn't it? So sometimes we have one root, sometimes we have two, sometimes we don't have any. All right, what does the next one say?
F of x equals 2x squared.
2x squared what?
2x squared minus 8x plus 5.
Okay. What's my a value?
2.
B?
Negative 8.
Good. C?
5.
Okay. X equals negative b over 2a. That's an a. So I get negative negative 8. And 2 times 2. What's negative negative 8? Positive 8. What's 8 over 4? 2. So my axis of symmetry is x equals 2. The x component of my vertex is 2. We take that 2, plug it in. 2 squared is 4. 4 times 2 is 8. Negative 8 times 2 is negative 16 plus 5. Negative 3, cool. So 2, negative 3. There's our vertex. Our axis of symmetry is right here. Cool. Does it grow by 1, 3, 5?
No.
What do I have to multiply by everything?
2, 6, 10.
Yeah, it's going to be 2, 6, and 10. That's probably going to grow too quickly to get a whole bunch more on there, so I'm going to go right 1 up 2, left 1 up 2, right 1 up 6, 2, 3, 4, 5, 6, left 1 up 6. Oh, I found where it crosses the y-intercept. Can I see exactly where it crosses the x-axis? No, I mean, there and there, those are probably irrational. Okay, there's some decimal amount. You can tell about where they cross, but not exactly. Number 4, what does it say?
F of x equals 2x squared plus 8x plus 6.
Okay. So, paste. So my a value is 2, my b value is 8, my c value is 6. X equals negative b over 2a. So I get negative 8 over 2 times 2. 2 times 2 is 4, so what's negative 8 over 4? Negative 2, sweet. So my vertex is at negative 2 comma something. So negative 2 squared is 4. 4 times 2 is 8. And then 8 times negative 2 is negative 16 plus 6. So 8 and 6 added together give me 14. Negative 16 added to 14 is negative 2. Negative 2, negative 2. Axis of symmetry. Right there. And then, does this grow 1, 3, 5? No. It grows twice as fast as that, right? So it grows 2, 6, and 10. Everyone okay with that? So right 1 up 1, or right 1 up 2, excuse me. Left 1 up 2. What did I just find? Couple roots, right? Okay, and then I'm going to go right 1 up 6. Now we're across the y-axis. Easily can identify those points. These are definitely my roots.
Will we have a question asking where it crosses the y-axis?
Sometimes it would be. The nice thing is, it crosses the y-axis every time at 0, comma, C.
C.
We have our ABC. So look where it crosses the y-axis. 0, 1, 2, 3, 4, 5, 6. So 0, comma, C is always every time. Yeah.
Okay, so considering how you found 2x2, considering how you use -2 and 2x2 to find the sum of that, wouldn't you do first do 2 times -2 and then you get -4 and then
Order of operations says do the exponent first, though. So -2 squared gives you +4, and then 2 times 4. Is that all right? Cool. Good question. Yeah, you will see where it crosses the y-axis, or the y-axis every time. It's 0, comma, C every time. What's the next one say?
Okay. F at x equals x squared minus 2x plus 3.
So where does that cross the y-axis? 0, 3. Yeah. All right, my A value is 1, my B value is -2, my C value is 3. X equals -b over 2a. So x equals -2 over 2 times 1. What's -2? 2. What's 2 over 2? 1. Cool. So the x component of my vertex, plug 1 in. 1 squared is 1. Minus 2 times 1 plus 3. 1 minus 2 is -1. -1 plus 3 is 2, I believe. Right? So 1, comma 2. Axis of symmetry is here. And then let's see, does it grow at 1, 3, 5? Sure does. So right 1 up 1, left 1 up 1. Oh, look at that, 0, comma C. Cool. And then right 1 up 1, 2, 3, 4, 5. Left 1 up 5. And that's about as far as we can go because we'll go off the grid. Hey, what can you tell me about the roots here? Yeah, they don't exist in the real number system. So the roots in this situation are actually called complex numbers. Okay? They do exist, they just don't exist using real numbers as far as the real number category. We need to start renaming the number systems. We need to, like, the real number system, let's change it to, these are numbers you see every day. And then the complex numbers, these are numbers that they told you from 8th grade down never existed. I don't know. Is that okay? Make sense? Everyone feel okay to cross the x-axis? That's where the complex numbers. So a complex number is if you were to try and solve it, you would get a square root of a negative number. And at this point, you've known that a square root of a negative number doesn't exist. All right, is there one more or am I done? What's the last one say?
F at x equals x squared minus 9.
X squared minus 9. Hey, am I missing a value up there?
Yeah.
Which one? A, B, or C?
B.
B. Sure am. Good.
You know where it crosses the
Yeah, you can get where it crosses.
in the x-intercept.
Yeah. So you saw that right away. So 0, 9, 1, 2, 3, 4, 5, 6, 7, 9. Is that 9 right there? So there's all kinds of things down here. If you saw this right away, good for you. And this does indeed graph as 1, 3, and 5. So right 1 up 1, left 1 up 1, right 1 up 1, 2, 3, left 1 up 3, right 1 up 5, 2, 3, 4, 5. Hey, what did I just find? Left 1 up 5. And I could even go right 1 up 7 if I wanted to.
I have a question.
Left 1 up 7. Talk to me.
So, if there's not a B value, you should skip the whole thing and just do that. So
Good.
Why is that? That's
Because our A value is 1, our B value is 0, and our C value is -1. So if I go x equals negative b over 2a, I'm going to get x equals -0 over 2 times 1. 0 divided by a number is always 0. So then we get 0 comma something, plug 0 in, 0 squared, 0, 0 minus 9, -9.
so it's like always if there's never a b value, you just graph the negative.
You can.
value of
Or you can go through our spiel. So either way. Look at that, we got all kinds of points on that, don't we? What are these? What are these? Yeah, I got roots. I know exactly what the solutions are. So sometimes what crosses the y-axis can be the vertex, which is this case. How do you feel about this stuff?
Yeah, it's pretty good.
It's not the worst thing out there, is it?
So the range on that would be negative infinity to negative 9.
Did we ask for
to 0.
So the range on this one would be -9, yep, to infinity. Good deal. So if I went back, the range on that one would be what?
0 to infinity or negative.
Nope.
-2
2 to infinity.
2. I thought it was
What's the range on that one?
negative 2.
-2 to infinity. What's the range on that one?
Negative 3.
-3 to infinity. What's the range on that one? Careful.
4.
Negative infinity to 4. What's the range on that one? 0 to infinity. I think that's it. Yeah. Cool. All right. So, if you would, make sure your name is on that assignment and anything else you're passing forward. And pass it on in, please. Just you don't need to take notes on this, just watch. So when I was a kid, a few things that are strange is me being when I was a child. One, my friends and I, we all had boats. Our parents had boats, and our parents would trust us from age 16 on to hitch up our trucks to the boats, drive our boats up to the lakes, and we'd go to different lakes, go water skiing and jumping off the cliffs and stuff like that. I don't know how we were trusted to, take our parents' boats out, but we were. And very few bad things took place as far as injuries go. But there was a lake in Arizona called Apache Lake. And so let's say this is the water line. Then off to the side, you had, coming out of the water, you had these cliffs that kind of, and then on this cliff there's like a rock at the top. So, you had people, they jump off this cliff into the water, and they jump off this cliff into the water. That was a far jump. Then you had people just do one of these into the water. Well, this was called the two screamer. You could scream twice on the way down. It was far. You're ah! Ah! It was a far drop. So we always wished we had probably bought actually mechanical devices to figure out how far things were. But the two screamer basically was a 4-second drop. Okay, now I want you to think about what a 4-second drop feels like. Ready? This will be 4 seconds. Think about you are in the air for this amount of time. Ready? Now. Hit. Gives you a lot of time to think, right? Yeah.
When you hop out of an airplane.
Yeah, okay.
Don't you have 60 seconds before you hit the ground?
Depends upon the height you jump from. Yeah. So the nice thing is free fall of an object, which is basically what you're doing. Even if you jump up, you're still in free fall. And you accelerate towards the earth at a certain rate. Now, there is something that if you do jump out of an airplane, you can get to something called terminal velocity, meaning you can't get yourself moving any faster because your body itself or your object itself is being buoyant in the air. So the air is pushing up on you as fast as you're trying to push down. But as far as limited distances go, you can get up to a pretty good speed and rate very nicely. But as you free fall, you can figure out how tall distances are. So 4 seconds, that's a lot of time. I just gave you the demonstration what 4 seconds would be like. But think of yourself, if you were jumping off an object or a cliff into the lake, that's a long time to think. And the hard thing is, if you climbed up to this area right here and jumped into the lake, you're like, no big deal. Oh, that was fun. Even if you climbed up to here, that was pretty fun. When you climbed up to here and you looked over, the boat that your friends are sitting on still out here starts looking small. This is the boat. Let's just pretend like I'm a good artist. Okay? The boat starts looking small. Like your friends are looking and going, hey, what's up? I mean, it's like you could cover that boat up with your thumb. That's how small the boat was. Though it was a 30-foot Sea Ray or Boston Whaler or whoever's boat we were in at the time. Now, if you climbed up onto this rock, that boat was really small. So, distance equals 1/2 AT squared. Okay, so why this becomes a parabola or a quadratic function is because you have a value that's squared. Now, there's a few constants up here we know. This is acceleration due to gravity. Yes, we can say negative 9.81 meters per second squared, but let's face it, we live in America. We have no idea what the heck a meter is. So we can plug in this as negative 22 feet per second squared. That's the acceleration that Earth is pulling us back in feet. Okay? So let's figure out what this distance is. Distance is equal to 1/2, that's a constant, times negative 22, and then times squared. What is the time we have up there? 4. Hey, yeah, and no. Do you need a signature on that one again?
Yes, please.
Okay.
Hey, Sean,
There you go.
one's for you.
Yeah.
One's for you.
Uh-oh. You got in big trouble. So, let's use the math here and figure this out. We can go slow. So, 1/2 times negative 22. Exponent would say take care of this, so that's 16. Still with me? 1/2 times negative 22 is negative 11 times 16. If I multiply that, I got negative 176. So, by all intents and purposes, none of us should have survived jumping off that rock. For some reason, we did.
Maybe you guys got a
Yeah.
little bit brain damage.
How did you get
Just a
That
little.
could
like
be.
super bad like
Wait, did you guys like point yourselves? Because like if you hit the ground flat-footed, it's basically cement.
Right, so the nice thing is the water is kind of churning. So your surface area of the water doesn't have the tension strength, which is good. If it didn't, you'd be actually, people's knees would have been going, okay?
Ew.
So,
did it
so
hurt?
you survived the cold water, right?
Huh?
You survived the cold water?
Well, yeah, I'm here right now.
When did you do that?
When we were about your age, maybe a little bit old, maybe a year older.
16 years old.
But the thing is, we would go with our parents, and they'd take us to these cliffs, so then we would take friends with us, and it was always funny. Now, the funny thing was, if you made it up to here, the hike back down was far worse than the hike up. I don't know if any of you are climbers, but one thing you do realize is it's so much harder to get down because you can't see the footholds and the handholds that you had seen on the way up. So you'd get people, they would try and climb down. There was a couple people who were in tears, like, I can't do it. And you're like, dude, just do it. We all survived. I will tell you, there's 176 feet. Think about this. That's a 17-story building.
Oh my lord.
Yeah.
How did you get all the way up there?
Now, I might be off a smidge on this, but basically our counting methods when we were kids were 1001, 1002, 1003, 1004.
That's not
So, if that was truly a 4-second drop, it would have been that. Do I think it was truly 100% 4 second? Again, we're counting as seconds. We didn't have cell phones at the time, so we didn't have stopwatches. We couldn't take videos of it. We didn't have this stuff. But I will tell you that was a far drop, and it was always called the two screamer or the double screamer. It was frightening when you're up on that rock and you're looking down, and you see people way down below. I mean, when you leap, you are cognitively thinking, oh my gosh, that water's coming fast. And that's what it was.
Where is this? Can we go and do this?
It was at Apache Lake in Arizona.
I think when we turn 18, we should go skydiving.
So,
Let's do it.
You can do it at 16 as long as you're proud.
yeah.
Oh, well, I don't want it with my parents.
Oh, there were mistakes that were made. There were people that tried flips off of it.
Oh boy.
They might have gotten all the way around and then some.
But did they like do really fun?
Oh, yeah. Oh, there
Oh
were
my
people,
gosh.
they'd be, you're yanking them out of the boat. I can't breathe.
Did people like ever jump off and then like hit the rock at the bottom?
No, everything was actually, it was slanted over really well. Like if you look, if this was the edge of the cliff, the water actually was back behind you. It like hung over. So you could step off like this.
Oh.
And the depth finder with the boats, because there's little depth finders, the water was over 60 feet deep. So there's no way you're hitting the bottom of the water because the buoyancy of yourself in water will not allow you to accelerate in the water very far. Yeah.
I remember one time I visited Oregon. One of my friends was at 85-foot bridge and said like no jumping, and he jumped, and when he jumped, he slipped. And like I remember we like counted it, but like we didn't know all this math and stuff. We counted, but when he slipped, he like went chest first, and then we took him to the hospital.
Ooh, man.
But he did like a double and then smashed.
Yeah, there is a certain limit where you should. It's not a survivable jump. For some reason, if one person made it, then we looked at it as, well, if they made it, I can make it.
Who was first?
You're so right. Though once you get to like the top.
Matt Owens, my best friend.
You did jump off that cliff?
Oh yeah, it's frightening. Now, if I were to do it right now, I would not do it. I'm telling you, my frontal lobe developed in my brain to allow reasoning to say, I shouldn't do that. I remember when we'd be on the boats, our parents would be like, don't go up too high, which is clear message to kids of climb as high as you can and try it.
Okay, so.
And I remember Matt Owens was the first that went off that top rock. And if Matt made it, I can make it.
Wait, okay, so you're saying you climbed up 17 stories.
Yeah, you went up these cliff faces. I mean,
Did you rock climb?
it was scrambling. It wasn't, it was maybe class 3. You didn't need ropes or harnesses because it was easy enough. But on the climb down, it wasn't because you still even couldn't see it.
What if you were leaning back? Would you fall into the water, or would you hit the?
If you leaned back on the sideways climb, you would have hit the rocks below here. So it was as you came off. So this was hanging over like this. This was hanging over. This was hanging over. It was amazing. A lot of people made this jump. They would not make this jump though. And this was a pretty tall boulder. but they didn't have the guts to climb the. I mean, it was kind of weird. You're looking at this huge rock that probably weighed more than the summation of all of our weight in this room, and it was pretty tall. It was a little bit taller than the ceiling. You kind of had to.
The boulder was?
Yeah.
No, it's
Did
Michigan.
anyone fall climbing down the rock?
Oh, there was people. There was skin knees, and I mean, you're climbing up barefoot. I mean, of course, it's in Arizona, so it's 118 degrees. So everything where you step, that rock is like, lava.
Has anybody like pushed you into the?
No, well, I'm sure at some point somebody who had gone there. We didn't really push people. We would razz them. There was times people would be climbing down and we'd drive the boats away, and that was really far from the docks, so you couldn't swim it
That's so mean. Why would you do that?
because we were.
Because it's funny.
So good stuff. Good
Oh
stuff.
my God, if you left me, I probably.
All right, so the nice thing about this is it truly does work as far as a parabola goes. It is definitely an applied situation. What I'd like you to work on for tonight, you have the rest of the period to start on it, is page 85, and it's just the front. It's just the front, so you don't have to worry about the back of it, okay? Which is pretty cool.